So there is an inclined plane. Four objects are made to roll down the inclined plane. So the question is, which one reaches the bottom first? So all the four objects are round objects. So let us assume that they're all round objects. They roll down. It can be, the things are, say, a ring. It is a ring, a disc, a shell, sphere, all with same radius r. They start to roll down simultaneously. Which one reaches the bottom first? You know that the time taken, so they will accelerate downwards this way, and the time taken to reach the bottom, in the last class we had actually derived. So the time to reach the bottom is given by this relation root over 2h into 1 plus k square by r square. If you have not seen that, you just watch that completely and come back here. It is 2h root over 2h into 1 plus k square by r square by g sine theta, where k is the radius of gyration. Okay, then there is also another way. So we have also found out that acceleration equal to g sine theta by 1 plus k square by r square. So either you can use either acceleration to find out or the time. Anyway, which one reaches the bottom first? So you can take the time. So the four objects are, let us write those objects like a ring, and then let me write here a ring, sphere, shell and disc. A ring, a disc, a shell, a sphere. Four objects. And you know the moment of inertia of all of them. A ring's moment of inertia I is equal to m r square. Moment of inertia of the disc is m r square by 2. Shell is I equal to 2 by 3 m r square, which can also be written as m into 2 by 3 r square. And sphere is 2 by 5 m r square. We will write m into 2 by 5 r square. Why? Because moment of inertia of anything can be written as mass into k square, radius of gyration square. Apart from mass, whatever is left is k square. So for a ring, k square is equal to r square. For a disc, k square is equal to r square by 2. For a shell, k square is equal to 2 by 3 r square. For a sphere, k square equal to 2 by 5 r square. Then in this case, we already know that time is equal to this much. The one which has least k square will have least time. The one which have most k square will have more time. So here k square is r square. This is r square by 2. So the disk comes faster than ring. But more than this, 2 by 3 r square, which is even lesser than that. This is 0.5 r square, 0.5 r square. And this one is 2 by 3 r square. This is around 0.66, right? So what happens? We will try this. So it is 2 by 3. 2 divided by 3 is around this. And here 2 by 5. So 0.4 r square, and this one is 0.67 r square. If you look at all this, and who comes first? Of all, this has the highest value, and this comes second highest, this is third highest, this is the least. Then obviously the time for this, so remember this relation, it is 2h root over 1 plus k square by r square by g sine square. Theta is common for all of them. H is common for all of them are allowed to roll down from the same height. So the only thing is this governs. So 2h by g sine square theta is common. So let us take that as a constant c. So the time for this t equal to time for the ring is root over 2h by g sine square theta into 1 plus k square by r square. K square is r square by r square, and time for the disk equal to root over 2h into 1 plus r square by 2, r square by 2 by r square by g sine square theta, and time for the shell equal to root over 2h into 1 plus, this is 2 by 3 r square, 2 by 3 r square by r square divided by g sine square theta. What I have done is, in this place of k square, I am substituting for ring, disk, shell and sphere. And for sphere, t sphere, this is shell, so root over 2h into 1 plus 2 by 5 r square by r square by g sine square theta. 2h by g sine square theta is common for all of them. So let us say time for the ring is root over some constant. This whole thing, let us take it as c into r square r square. So it is 2. For time for the disk is equal to root over c into 1 plus this r square will be cancelled, 1 by 2, which is 3 by 2. Time for the shell equal to root over c times r square will be cancelled, 1 plus 2 by 3, so 5 by 3, c times 5 by 3. And time for the sphere equal to root over c into, this is 1 plus r square will be 1 plus 2 by 5, which is 7 by 5, 7 by 5. Now if you look at all of them, this takes the longer time, so this reaches the ground at the last. So time for the ring is greater than, this is 3 by 2, 1.5, this one 5 by 3, so 3 by 2 is 1.5 and 5 by 3 is 1.67. so time for the shell is more than time for the disk, which is more than time for the sphere. So sphere reaches the ground at first, because this one 7 by 5, so 7 by 5 is actually 1.4, this value is 1.4, this value is 0. This is 1. Then 6, 7 something, this is 1.5, this is 2. So now this first, this comes first, this comes second, disk, and then the shell, and then the ring.